Okay, good morning everyone. So today we are going to have the final session of this online course on integrated waste management for a smart city. And this is basically an extra session where what I have done is that I have compiled some of the interesting or basic questions which we have covered from week 1 to week 11, and that is what we will try to cover in today's session, which will be for 1 hour and will conclude at 12 noon IST. So before I start this session, I would like to introduce myself first for the final time in this course for this year. So I am Radarshi Bhar and I am doing my PhD from IIT Kharagpur under the supervision of Professor Brajesh Kumar Dubey and Professor Makarand Madhav Bhande. So I think we can start the session now. So I will quickly go through these questions and wait for 1 minute since most of these are theoretical based questions. So the first question is, which of the following is the most favored method for waste management? Recycling, waste minimization, disposal, or reuse? So the thing is, if I look at first option, that is recycling. So recycling, okay, it's fine. But if I try to look at the pyramid or the hierarchy which is preferred to manage the waste to ease that burden, so among these four options, disposal, it comes at the bottom. So I'll try to build it. This is disposal because that means there is no further use of the material that we are disposing and it is dumped in at some point. After that or above it comes recycling. So you can recycle the residue or waste stream or solid waste. Maybe you have to process it first a little bit. For example, you have those glass cold drink bottles. Once you have the cold drink, you have to keep those glass bottles in crates. Those crates then go to certain facilities. In those facilities, they are washed, cleansed, chemicals are applied on them to prevent any kind of hazards that the next batch of use may have on us who are consuming that cold drink. So those things include some sort of processing, cleaning, washing, chemical treatment, heat treatment, little bit all those stuff. After that, you can either if it is crushed and used for some other purpose, you can do that. So there are some processes involved. So that is why it is recycling. Since you are putting in some effort to again bring it to use. And above that, we have reuse. Now this you can relate to those 10, 20 liter bottles, because once you like these plastic bottles you have the drink, then again you use it for several times. Okay, so there is a threshold because there have been several studies which indicate that with the passage of time, there is also another risk of generation of microplastics and its consumption and presence in human bodies. But let's assume that for certain number of times you won't have that risk. So keeping that point in mind, we can say that you are using that plastic bottle again and again. So that is reuse as per the word definition of the word itself. So that is another way how you are helping it. After reuse, the best possible scenario that comes and which should be adopted everywhere and people also recognize that it is waste minimization. That is taking steps or adopting strategies which will help us to reduce the generation of the waste itself. This is kind of addressing the problem right at the source, right? Because how can this be managed? For example, when we are designing any product, there are companies who are actively working on this, and government also pushes for the same. That you have to design your product in such a way that at the end of life, the waste that is generated from your product it is bare minimum. Like that is what everyone recommends and tries to achieve, keeping that economic aspect in mind. Now, no one will sacrifice their profits that to abnormally high trade-offs, which is bad for them for waste minimization. So you need to stand at some equilibrium with the economy and the environment to make people go for this more greener approaches. After that, so in this particular question, the correct answer is waste minimization. In this question, next one, the question says that the greenhouse effect of methane and carbon dioxide, that we know that both methane and carbon dioxide they are greenhouse gases, and there are four statements in here. So you have to choose like which one is the correct. Whether methane is less potent GHG than carbon dioxide, or methane is in fact not a GHG altogether. So these are the 4 points you can think about it. Hello, hello, लैब में लैब में ठीक है 12 बजे चलते हैं मेरा 12 बजे तक मीटिंग है हाँ हाँ ठीक है हम्म Okay, so in this particular question, the greenhouse effect of methane and carbon dioxide, like regarding that, this particular aspect, there have been four statements. First is that the methane is less potent GHG than CO2. Second one is saying that CH4 is not at all a GHG, but CO2 is. Then third one is saying that neither CH4 nor CO2 are GHGs, greenhouse gases. And fourth, the final one says that methane is more potent GHG than carbon dioxide. So among these four options, option D is the correct answer, that methane is more potent greenhouse gas than carbon dioxide. To be a bit more precise, I think it is around 25 or 27 times more, is having higher potential than carbon dioxide. Then coming to the next question, like during degradation of waste in landfills, there are a lot of gases which are emitted, or not emitted, like if it is an open landfill and no gas collection well and all are there. So then this question comes. Otherwise, there is a better statement is there are a lot of gases which are generated. So, which among the following do you think is combustible in nature? So, you can use the chat box to answer the question, or I will wait for about 15-30 seconds and then discuss the same. Very easy, simple question. Landfill, we all know that is, and basically the major part of it, it is an anaerobic process So the gases which are formed during anaerobic degradation, the signature gases, they are methane and carbon monoxide. The CO2 and H2O, these are mostly the products of aerobic processes. So taking the nature of landfill into consideration, we have first shortlisted the options to option C and option D, like either one of them can be a combustible gas during degradation of waste in landfills. And among them, we know that methane is the one, which is the correct answer, which is also being looked as a substitute for various other fossil energy sources. After this, in this particular question, you have been asked that in order to prepare a compost from there are following four types of waste streams, which of this can be used to make a compost out of it? Glass, metal, food waste, or plastic? So among these four, so among these four, this glass and metal are inorganic in nature, so they can't be degraded. No question about degradation. Plastic is non-biodegradable, the mostly used one. And then what we are left with the obvious choice is food waste, which is biodegradable in nature. The next question: which of the following is not a waste to energy approach? So, which of the following is not a waste to energy approach? Whether it is composting, mass burning, combustion of RD, or all of them. In this particular question, if you are looking at a waste to energy approach, and let's talk about composting. Okay, so you have a waste which is preferably or which is must be organic in nature, biodegradable. So you convert it into some what is it, fertilizer, manure, and all those nutrient-rich material which you can apply for soils and irrigation and not irrigation, soil amendment and other agricultural uses. So the end product is having some value, but it is not energy. And if you talk about mass burning means you take a whole dump of waste, you burn it. Yes, the waste is getting burnt. There is energy coming out of that burning, but you can't tap into it. It is directly getting wasted. So that is why the waste is not, it is converted to energy, but in the waste to energy concept, we say that the energy that is generated, we are able to tap into that energy, we are able to make some use out of it. So mass to burning is also out of question. But if you take a look at this combustion of RDF, so RDF are refuse derived fuels. So what happens is that refuse means the waste and the fuel which is derived out of that refuse. Now it can be done in various ways. One thing is that when the municipal solid waste comes in, so you segregate the waste which are having high calorific value. Once it is segregated, next thing is you compress that waste into small cubes, the cubes or any shape as per the requirement. So now we know that if like 1 kg of mass is there, it is occupying this much volume, and if the same is compressed and it occupies a lower volume, that means it is more easy to transport, more easy to handle. So, and in fact, in terms of volume also, handling also, if you are putting it into some boiler or something for burning, so the lower volume it you are getting, and if you convert that, for example, 1 kg of waste is there, so it is having a calorific value, let's say 30 megajoule per kg, and you have a boiler which is having a volume of, let's say, 20 liters. Fine. So I will make a diagram here so that it is easy. So this is a boiler. Boiler volume is equal to 20 liters. Fine. This is where you will put your RDF. And now you have got two types of RDF. This is RDF Like this is not an RDF, basically this is the solid waste, and I will type write solid waste as SW, and both of them have the mass of 1 kg. Fine, but this solid waste is having a volume of, let's say, 10 liters, and this is again, this solid waste is again the one which is compressed. So I will write here solid waste, uh, compressed solid waste, CSW. And due to compression, let's say it occupies a volume of 2.5, 2.5, let's say 2 liters after compression. And the energy content of this solid waste, now see, so this is, let's say, this solid waste initial which was segregated. So both of their masses are 1 kg each, and the energy content of this 1 kg mass is, you can see the calorific value is 30 megajoule per kg, and this boiler is having a volume of 20 liters. So one thing is done, like if you have compressed it, then how much volume can fit inside the boiler? 20 liters compressed solid waste. Each block or each cube or each sphere, it is having a volume of 2 liters. So total volume 20 liters, each having 2 liters. So number of units you need, 20 divided by 2, that is 10. So you can have 10 such compressed solid waste blocks or spheres to be added to the boiler, and there you can burn it and get the energy. So 10 such blocks, and each block is having a mass of how much? 1 kgs. So 10 blocks is having a mass of 10 kgs. Energy that you need from, that you can gain from each kg, is 30 megajoules. So 10 kg you can fit into this boiler, this compressed, if you are using these compressed solid waste blocks. So 10 kgs you can put in. So in terms of energy, how much energy you can gain? 300 megajoules. Now this is one scenario. Now let's say we are having another scenario where the solid waste is not compressed, it is sitting like that, 10 liters, and the weight is same. This weight is also, you can have the same weight, 1 kg. And now if you want to fit this into the boiler, total volume of the boiler 20 liters, the uncompressed solid waste volume is 10 liters. So how many such units you can put in? 2 units, 20 divided by 10. So 2 units, each unit is again having a mass of 1 kg. So there are 2 units, then that means 30 megajoule per kg into 2, that is only 60 megajoules you can gain if you burn uncompressed solid mass, solid waste in this boiler. So now you can understand that here, if you are not compressing it and using it in a boiler, you will gain an energy of 60 megajoule. On the other hand, if you compress it and then use, then you can get a energy of 300 megajoules, 5 times higher. So I hope you can understand that. So that is why combustion of refuse derived fuel, this is waste to energy approach, and there can be various ways to prepare this refuse derived fuel. If you use this waste, you can treat it in different ways. There are various processes like hydrothermal carbonization, where the waste, if it is wet in nature, you put it into a sealed container. Basically it is occurring under a temperature of, let's say, 150 or 120 to 180, or not 180 to 280 degrees centigrade, and there is some auto generated pressure of up to 60-70 bars. So 670 bars means 6-7 megapascal. Yeah, no, not 60-70 bars, it is more like 50 bars, so 5 megapascal. So that is the range where hydrothermal carbonization occurs. We put in some wet waste into it. Preferably the particle size of the should be smaller, because smaller the particle size, better is the reaction. And then at the end of the reaction, which has taken place under a certain temperature, under auto generated pressure, because it is wet, once you start heating it, the vapors start to form. Since it is a sealed container, after a certain time it can't get out of the container, and there is a kind of equilibrium between, at a particular temperature, there is an equilibrium between the vapor and the liquid phase. And in those temperatures, various reactions starts to occur: hydrolysis, decarboxylation, dehydration, and then repolymerization and aromatization also occurs. So at the end of this, hydrochar is formed in the form of a slurry. This hydrochar is a very carbon rich material which is having, usually or typically having, higher energy content than the initial feedstock that was used in hydrothermal carbonization. So then that slurry is again filtered and then dried, and the obtained biomass, sorry, not biomass, hydrochar, you can compress it, make pellets out of it, and then use it as RDF. So that is why in this particular question, option C, that is combustion of RDF, is the correct answer. Then next question is, acetic acid formed in landfill degradation process is the substrate for which of the following specific microbe? Fine. So the question is saying that acetic acid is formed during landfill degradation process. Is the substrate, and by substrate in common words I would like to say that is food for which of the following specific microbes? So in order to understand, you need to first have to acknowledge basic, that the sequence of typical anaerobic degradation process. So what happens first? I will prepare it. First step is hydrolysis, then acidogenesis, then acetogenesis, then methanogenesis. Fine. These are the sequential steps which takes place during a typical anaerobic digestion process. So the acids, acetic acid, which is formed in this particular step, like some acetogenins, acetic acid is also found in step 2 acetogenesis, but its concentration increases in step 3, that is acetogenesis, like a huge amount of it is, you can say that it is specifically uh, designed or working in such a way that acetic acid production is the major product, one of the major products. So you can see that the acetic acid produced here, it is then used by the methanogens. It is then used by the methanogens as the food for producing methane. So that is why acetic acid is used by methanogenic bacteria as the substrate. In acetogens, various volatile fatty acids are formed, among which fatty acids this acetic acid is one of the components. Then next question is, maximum BOD occurs in which phase of waste stabilization process in landfill? So if you take a look at the different processes, you will see that first is preliminary aerobic, then acid forming, then methane forming, the longer one, and then final aerobic. So if you take a look, where is the BOD maximum? It is maximum at the acid forming stage, because what happens is, after hydrolysis, what happens, the soluble BOD, that is getting into the solution or into the organic matrix, that can be degraded, it is keeping on increasing because it is degraded and formed and transformed into either VFAs or acetic acids. So that is why in acid forming stage you can see that they are, this graph, it is basically evaluating the leachate characteristics. So as with the process with the hydrolysis, these organic materials, they keep on degrading in and then starts forming acids, because that is also one of the processes, acidogenesis and acetogenesis. So the acid concentration of VFA concentration, it reaches a peak at some point, and that point is also where the maximum BOD can be found. So that is why the correct answer for this question is the maximum BOD occurs during acid forming stage. After acid forming stage is there, then methanogenic bacteria actively play their role. Methane starts forming, and you can see that the BOD it also falls down and gradually stables at a much lower concentration. Now moving to next question, a very simple numerical based question. It says that the moisture content of a waste is 68% and the initial weight of solid waste plus crucible is 50.23 per gram. Empty weight of the dry crucible is 30.63 gram. What is the dry waste or solid waste? Very simple. Initial weight of the solid waste, what it is? You need to subtract the weight of the crucible from 50.23. What is the empty weight of the dry crucible? 30.63. So subtract 30.63 from 50.23. That is what I have subtracted here. And this value will give you the initial weight of the solid waste. Now you want to know how much water is in there. Fine. The question basically asks the dry weight of the solid waste. That is what we don't know. So what we know is the moisture content. So we are fitting this data that we have into that equation. So this initial weight of the solid waste minus x, which is the final weight of the solid waste. If I subtract x from this value, obviously I can get the water content. And then denominator will be the total mass of solid waste. Total mass is again the same 50.23 minus 30.63 into 100 is equal to 68%, which is given in the question. So now if you solve this equation, very simple, x will come out to be, that is dry weight of solid waste will come out to be 6.27 grams. Now next question, which arrangement is generally used for gas collection at landfill? So for collecting the gas at landfill, we use leachate wells. Sorry, not leachate wells, this vertical and horizontal gas collection wells. These are used for gas collection. These leachate wells and geotextiles, these are all, and liners, you remember, they are more typically associated with leachate collection and its control, like to prevent the seepage of leakage into the, like from the liner to more depths and to prevent the contamination of the groundwater. After that, in this question, this is a chemical EDTA, and the chemical formula is written C10H16N2NO8, and you have to calculate the heating value. So it is very simple. If you know the Dulong's equation, which is also shown here, you have to put the percentage fraction of the carbon, hydrogen, nitrogen, and oxygen in here in place of C, H, O, S, and N, and then the value that you get, it will be the heating value in BTU per pound. So this is what we have done here. So we have first calculated the percentage carbon. There are 10 carbon atoms. So 10 into mass of each carbon is 12 grams molar mass. So 10 into 12 divided by the total molar mass of this EDTA. That is what we have done. Added all the elements up, their masses, and then the carbon percentage is 41.5. Similar way, we have calculated H, O, and N, and S is 0, sulfur. So put it into the BTU equation, Dulong's equation, and then we get the answer, which is 6070.75 BTU per pound. The next question is, what is the preferred measurement unit for chemicals present in solution? Again, a very simple one. So the correct answer is milligram per liters or ppm. Then, which of the following is, that is a very important question, which of the following is the costliest operation of solid waste management, whether it is storage, collection, transport, treatment, all, or the final option is that all are equally costly. So collection and transport. This is the most costliest phase of the solid waste management system. You can understand that while like there are a whole different set of calculations to arrive to this point, but some of the major factors that play their role, it is like you want to collect waste from locality or a huge area. So taking the Indian scenario, you need different types of vehicles. Not each vehicle can enter into alleys to collect the waste from individual households where such waste collection management approach is taken. So you need smaller vehicles, then you need people, one driving the vehicle and then maybe another one who is dumping the waste into the different components of a vehicle. After that, the same vehicle, it goes way through different households, number of households, and then finally it reaches, let's say, a transfer station. So this is just for one vehicle, and to cover a huge area, there are a lot of vehicles that are there. Then there are bigger vehicles which can carry more waste, and if it can go through the like the roads and all in such a way that you can avoid smaller vehicles, because a single huge vehicle, it is usually more economical than you go for a much higher number of smaller vehicles to gather the same waste. So then you need fuel in this vehicle, and then you need to optimize the routing of that waste collection vehicle and all. So taking all those factors into consideration, the manpower, the fuel cost, the infrastructure, that is the vehicle fleet cost. So all of these makes the collection and transport of the waste to be the most costliest affair in the solid waste management system. Now in this particular question, you have been asked that what is the optimum C by N ratio of the solid waste composter. So you can see here, like the optimal range is 20 to 25 is to 1. So you can see this option B, 20-25 is to 1. So the other important points that we can gather from this slide, let's take a look at them. Individual component of organic waste have different C/N ratios that we know, because based on their nature, digestive sludge is having a low carbon content. So that is why it is having a lower C by N ratio. Yard waste is having a higher ratio, 40 to 80. Then newspapers, they are like very high, it's 175 to 800. So sometimes what we do is that you need to maintain that 20-25 ratio. So you may have to blend different components to achieve that. And also you need to consider their nature and degradability also. So coming to next question, pH of compost at what stage is between 7 and 7.5? So now if you take a look at this particular slide, you can see that it is clearly written that in mesophilic stage the pH is between 7 and 7.5. And after several days the pH will naturally drop to 5. And this drop, it is due to the production of various organic acids. And this drop in pH of not controlled it is also harmful for the quality of the compost. That is why it should be mixed after regular intervals. Just give me a moment. না আমি মোটামুটি 12:30 সময় হবে, কি আছে হয়ে গেছে এটা? আচ্ছা আমি তাহলে আসি, তারপরে চলি। ও করে দেবে না, ঠিক আছে। সামনে করো হাতটা, ওই অ্যাসিড ট্যাসিড আছে কিন্তু, সামনে করো। हाँ? वो क्लास है उसका 12 बजे। हम्म। Yeah. So to minimize the loss of nitrogen in the form of ammonia, because that is obviously prefers to stay in gas form, so the pH should be maintained below 8.5. And the matured compost, it is having a pH of around 7, which is near neutral. Which is, 7 is basically neutral, and the pH should be also near neutral. If there is an insufficient aeration that is mixing, there's a chance that pH will drop to 4.5, and then the composting process itself will be a problem because the quality of compost will degrade due to the inefficiency of the process. The next question is not a product, like which of the following is not a product of aerobic composting? So the correct answer is hydrogen sulfide. It is not a product of aerobic composting. So moving to the next question. হ্যালো, হ্যাঁ ক্লাস হয়ে গেছে? ঠিক আছে, তুই কোথায় আছিস বল, আমি আসছি। So the next question is which of the following thermal conversion techniques involves superheating of gas to an ionized state? So the correct answer is plasma R. That is the correct answer. The temperature is above easily above 10,000 degrees. Now the next question is this one. What is the oxygen requirement for complete combustion of 100 grams of methane? You take a look at this question and try to solve it, and then I will discuss this solution again in about 5-10 minutes. Okay, so what happens is that in this particular question, I think you must have guessed the approach by now. You have to basically carefully look into the stoichiometry. Methane, if you want to completely combust it, this is the reaction equation. 1 mole of methane reacts with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. So this is what we know. Then transform this moles to their molar weights. 1 mole of methane means 12 atomic weight of carbon, 1 atomic weight of hydrogen. Add them up, you get molecular weight 60. So get the molecular weight sorted. Then we have got 2 oxygen molecules, 2 moles. Fine. So each mole of the molecular weight of oxygen is 32. So 2 are there. So 64. Similarly, we have got the molar masses of the this, if there is sometimes 2 moles, so accordingly we have got the masses. Then apply simple unitary method. For this much gram you need 64 grams of oxygen for complete combustion. Then what will be for 100 grams? Simple. The same concept can be used if someone say asks you how much CO2 is formed, how much H2 is formed, like that. Now next is a question where you need to find the lignin content, and you have to like either remember this formula, or if it is given in the question, then you have to simply put it. Put this lignin content into this formula if you want to calculate the BVS, or if BVS is known, you can calculate the lignin content. After that, the combination of organic fraction of biodegradable components that remain after treatment and plastic is termed as residual volatile solids. Then excess air combustion of solid waste is done for which of the following purposes? It is done like you have the options, and the correct one is to ensure complete combustion, ensure that complete combustion occurs. If there's incomplete combustion, then you will see that carbon monoxide will be more in the stream if the carbon is not getting burnt completely, because it is not able to get oxidized fully. So option C is the correct answer. Then which of the following isn't one of the 4 phases of combustion? So before we are going to address this question, we will first take a look at the mechanism of combustion. The first and the most obvious phase, we have a mass, there is some moisture in it. So first phase is the drying phase where the moisture is removed, and it can go up to about 150 degrees centigrade. But usually if you keep it at 100 for some time, then also the moisture gets removed depending on how much moisture is there. Fine. So I'm not going to say that you see how food waste is. I'm not going to make sense of combusting the food waste. Fine. If you want to combust something, it can be, let's say, plastic waste, paper waste. Yes, there can be some moisture there due to various reasons. So in those cases, heat it for some time at 105 or up to 150, the moisture can be removed. Once it is done, the drying phase, phase 2 comes into picture. It is the volatilization of vapors and gases. This is the phase where the various volatiles they are getting released from the mass. If you look at the point, it is written that the combustible volatile organics diffuse out of their flash point out when their flash points occur. So those volatiles which are combustible, they then catch fire as they are released from the mass. Then burn down of solids. Then the fixed carbon which is there, after that it is burnt. And finally burn down of char. The remaining char is burned down to bottom ash. This material is the end product of the reaction. Now, if I take a look at this option, you can see that burn down of solids fine, volatilization of vapors and gases fine, burn down of char fine, but condensation of vapors to liquid, this is not a component of different phases of combustion. This is something like connected to a different concept, wherein if some vapors are released which are having various tar compounds, they can be again condensed, and then some liquid oil can be used, which can be used for as a fuel or various other applications. Then in next question, handling hazardous and medical waste, which option will you choose? Should you compost it? No. Hello? 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 जी? हाँ जी, बोल रहा हूँ। क्रेडिट कार्ड का क्या है? आईसीआईसी बैंक का? हाँ, जी जी। ओके। नो बट आई एम नॉट इंटरेस्टेड। नहीं नहीं, नहीं नहीं। थैंक यू। So for handling hazardous and medical waste, which options will you choose? Whether you should go for composting, rotary kiln combustion, anaerobization, or all of the above. So if you do go for composting, there can be various hazardous chemicals, which no question, like many of them are non-biodegradable. In fact, most of them. Then medical wastes can have various pathogens. That can be another risk that for composting, because once the compost in all those things, it comes in close contact with humans. Then rotary kiln combustion is there, where you can combust all these hazardous and medical wastes. That makes sense because you're burning everything kind of like completely getting rid of those if there are some pathogens and all, then anaerobic digestion and then all of that. So the question is about hazardous and medical waste, like the medical waste which can also be hazardous. So the best way to handle them is through rotary kiln combustion among these options. So then which of the following is not an advanced thermal treatment technique of solid waste management for solid waste management? So gasification, it is an advanced one, pyrolysis also, plasma is also, but mass burning is what? You take a mass, burn it. That is mass burning. No, there is no such advancement, I think. But if you take a look at gasification, it is basically done at a partially oxidative atmosphere, and the temperatures are usually very, very high, above 700, 600 degrees centigrade. And then the main end product that we want to get out of gasification, as the name itself says, it is gas. Now, if you come to pyrolysis, pyrolysis has again a thermal treatment which is taking place under inert conditions or inert atmosphere. You can maintain that inert atmosphere by, let's say, flowing nitrogen gas, which is very cheap as compared to other noble gases like helium, argon. These are very costly as compared to nitrogen. Then comes plasma, where complete mineralization, not mineralization, where completely all the bonds are broken and individual atoms and molecules are formed. Because the temperature is absolutely like very high as compared to pyrolysis and gasification, it is typically above 10,000 degrees centigrade. Now the next question is, which is the most important property of geonite that helps in collection of leachate during waste degradation in landfill? And in here, the right answer is transmissivity in horizontal direction. That is what it helps in. After that, the BUD is stabilized in which phase of the landfill? So if you take a look, I've already shown this curve before. The BUD is getting stabilized. This here, you can see it is getting stabilized somewhere in the methane forming stage. So the correct answer is methane forming stage. And another point I would like to add is that the BUD is highest, as we have already seen a few questions back. During the acid forming stage, where a lot of VFAs are generated, the concentration is highest. Correspondingly, the pH is also low. So these two curves are related. That is what I wanted to highlight. Then, what is the primary reason for flaring landfill gas? So, what are the major gases? And landfill is usually operating under anaerobic conditions. So methane is one of the major gases and carbon monoxide. So particularly if I look at methane, which is a greenhouse gas, 25-27 times more potent than carbon dioxide. If you're not able to capture it and then utilize it at some other place, and instead it is leaking or you're just emitting it into the atmosphere, then instead of carbon dioxide, you're in fact, you can see this is the combustion of methane to form carbon dioxide and water. So if you take a look, this should be like I have not balanced it. CH4 plus 2H2, this should be 2. So now if you take a look, 1 mole of methane then forms 1 mole of carbon dioxide. So same moles are there. So if 1 mole of methane is emitted, it is, you know, that 25-27 times more potent greenhouse gas than carbon dioxide. So that is the issue. So we flare it so that at least the methane it gets converted to CO2, which is less dangerous. That is the basic reason. Then the volumetric water content where plants can no longer draw moisture from soil is called. It is called wilting point, where the plant wilts because it doesn't have any capacity to draw moisture from the soil because the moisture is gone below wilting point in the soil. And now coming to the final question, the change of water from liquid phase to vapor phase from the plants through stomata openings is called. It is called transpiration. And if evaporation and transpiration both of them are taking place together, then it will be called evapotranspiration. Otherwise, simply the loss of uh, the change of water from liquid to, instead of vapor, it should be gas phase, or vapor can also be used through stomata openings which are present in leaves. So that is called transpiration. So these were the questions that we have gone through. Like most of these are some of the basic questions that I have collected from week 1 to week 11, mostly 12 since we just covered that yesterday. I have not included it, and hopefully this 12 live sessions for and this extra session must be helpful to those who are going through it. And thank you, NPTEL, for giving me this opportunity to take live sessions under the scheme, EMRF scheme. And I look forward to more such opportunities because it is a great learning for me as well. Interacting with different people here who often have very interesting questions helps me clarify much of my own concepts as well. So thank you again, and hopefully I can be a part of such more uh, sessions. Thank you. Take care. Goodbye.